Welcome, everyone. Thanks for joining us today for our latest webinar, Debugging GOOSE, How to Streamline Troubleshooting and System Validation. My name is Beth Capellas, and I'm the Marketing Manager here at Triangle Microworks. Before we get started, I have a couple of housekeeping items that I'd like to go over while folks are still joining. The webinar is scheduled to be 1 hour long. We do typically get a large amount of questions, so we're happy to stay on as long as possible to answer as many questions as we can. With that said, I'd like to encourage questions throughout the webinar. Since the audience is on mute, please submit your questions using the webinar menu under the section titled Questions. You can start asking questions as soon as you have them. Don't feel that you have to wait until the end. We will begin answering questions online as we have several engineers monitoring the questions and responding to them directly. We will also stop a couple of times throughout the webinar to read and answer questions. And of course, as I mentioned, there will be time dedicated at the end just for questions and answers. Next, I'd like to introduce our speakers, starting with Christoph Brunner. Christoph is a leading utility professional with over 30 years of industry experience with knowledge in both the utility and automation industry. He has been involved in the development of the 61850 standard since the beginning. He is president of IT for Power in Switzerland, a consulting company to the power industry. He is the organizer of the working groups responsible for the core parts of 61850. He is active in several working groups of the IEEE PSRC, which is the Power Engineering Society Relay Committee, and a member of the PSRC Main Committee and the Subcommittee H. He's a guest professor at Shandong University of Technology and an international advisor to the board of the UCA International User Group. We also have with us Jim Coates, president of Triangle Microworks. In 1994, he started Triangle Microworks to provide communication protocol software to the utility industry. And he continues as president with a primary role of product research and design. Jim is currently Chief Financial Officer of the DMP3 User Group and participates in the IEC Technical Committee 57 Working Group 10. Before we jump into the webinar topic, I would like to give a little background about Triangle Microworks and what we do. As I mentioned, we were established in 1994, and we have over 25 years experience working with Scada communication protocols. We have customers all around the world spanning over 70 countries, working with equipment manufacturers, system integrators, and electric utilities. Many of our employees sit on the standards committee, such as UCA and DMP user and technical committees. Staying active with these committees help us to stay up to date on the protocols, as well as influence the specs based on our customer needs and what we are seeing in the industry. We have several categories of products. We started with source code libraries for DMP3, 61850, 6870-5. That includes 101, 102, 103, and 104. We also have libraries for 6870-6, which is also known as TASI2 or ICCP, and for Modbus. We provide technical support not only during initial implementation of our libraries, but also support for any communication issues that may arise with your devices in the field. We have a collection of testing tools that support the standard Scada protocols, like 61850 Test Suite Pro, Distributed Test Manager, Test Harness, and Iron. Today, we'll be mostly focused on Test Suite Pro. You may have also heard about our Scada Data Gateway, which is a Windows application for protocol translation and concentration. Our gateway supports OPC and the Scada protocols mentioned earlier. We are planning to release a Linux version of the gateway in the next several weeks, so stay tuned for more information on that. And if you haven't already, please go to our website at trianglemicroworks.com and sign up for our newsletter for upcoming product releases and webinars. With that, I'd like to hand it over to Christoph to go ahead and get started. Okay, Christoph, you should now be presenter.
Well, I just shared the wrong screen. Sorry for that. We will split. Okay, so what I wanted to introduce here is a little bit the background of our demonstration today. For those of you that have been in previous webinars, they probably already know our little substation that we use as a demo application. So we have a substation with 2 lines, two transformer bays, various IDs, and as for the purpose of this demo, the substation will be simulated in DTM. So what we see here is the single line diagram of that substation with the 2 line bays and the 2 transformer bays that we will use as a playground for our testing. This slide shows the overview of the substation with the different IDs that we have in the base. So we see that we have in each of the bays basically 4 IDs, a bay control unit, a protection unit, either the line protection or the transformer protection unit. We also assume that we have a fully digital substation with switch control units and with merging units in each of the bays. On station level, we have an HMI, we have the busbar protection unit, a merging unit for the busbar voltages, and we also have designed in the system a client that we can use as a test client. That's in general a good practice when you do a 6150 system design. Make a spare client available where you can connect your test tool so that you can also get the reports and you don't need to rely on having reports from another HMI available that is not connected. As mentioned, this whole part here will, for the purpose of this demo, be simulated in DTM, but the testing would be exactly the same if you would have the real substation devices behind. The webinar today is mainly focused on GOOSE, so I provide a quick quick summary again about GOOSE messages. We have here an example of a GOOSE message where we use between a bay control unit and the switch control unit. As I mentioned, we assume a fully digital substation, so we have a separate device which is interfacing and controlling the switch. That's where, from a 6150 perspective, we implement the logic node XCBR. On the other side, we have our bay control unit, which implements the CSWI, and then we have the op-open and op-close signals that are going from the VCU to the SCU in order to perform the controlled operation. In a similar way, the protection device sends the trip or a retrip from a breaker file also as GOOSE over to the SCU. The whole system has been designed with Helink's STS, which is a system configuration tool and allows you to graphically design your signal flow that you are requiring to implement GOOSE messages. The GOOSE message itself, so what we have in XML then, is completely generated automatically by the tool, so you don't need to worry about configuring data sets, configuring XTREF, configuring GOOSE control blocks. The tool takes care of that for yourself. Another important element when we talk about GOOSE and GOOSE messages is the logical node LGOS that has been introduced in addition to of the standard. The LGOS basically tells you from an ID subscriber perspective if everything is okay, if it receives the message it is supposed to receive. So this is a good testing feature as well when you have these in the IDs, because sometimes when something doesn't work, you are never sure, is it not sent correctly? Does the device not receive it? Is it something internal in the device? With the LGOS, you get a clear indication if at least the interaction works, so if the device receives the GOOSE message. So that's something that we will see later on in the demonstration, how this can be useful to identify and classify possible problems that you have in your system configuration and implementation. With that, I will quickly give an overview on the different tests we want to demonstrate. In a first step, we will demonstrate how we can do a unit testing of a device. And then in the second step, we will demonstrate how we can do system testing. The unit testing of a device is basically, I mean, we can have multiple aspects of unit testing. A first one would, of course, be to do a full functional unit testing. So you have your device configured as you want it to have in your design. But before you build the complete system together, you want to be sure that each and every device behaves and is configured as you expect it, so that you can already eliminate these kind of configuration errors. When we do a full functional testing of the unit, we will need to simulate all the other devices that interact with the unit. We could do that as an example with DTM. But for today, where we focus on communication testing, we will only do a unit testing from the perspective of configuration and communication aspects. So basically, we will verify if the device is configured the way how it is also specified in the SCL file, in the system configuration description file. We will verify that the device is publishing all the Goose messages, and we will verify that the Goose messages the device is supposed to receive are also received by the device, so that everything is configured correctly from this perspective. And this you can do using just TSP and the device under test. And Jim will now go and demonstrate to you how this is done. So with that, I hand over to Jim.
Thank you, Christo.
Okay, Jim, you should now be presenter.
All right, can you see my screen?
Yes.
Great. Okay, so this is Test Suite Pro. You have tools over here on the left, and then this divider bar separates out the displays. The display buttons are down here, and you can see tooltips to get you familiar with what the different tools do and then displays do. So this is the system status group over here, and it shows you the error conditions that Test Suite Pro has detected automatically. And these should be resolved or acknowledged before using the other tools and displays. So this is kind of the overview. It shows the IDs and the connection status, the IP address, the Goose adapter, and so forth. You can see that since this is a unit test, most of the devices are not connected, but the device under test is connected and looks good. So we can go ahead and acknowledge these warnings, and we've kind of dealt with the system status indication. The next thing in the system status group is the compare model, and you can see that it goes through and does a discovery and compares that with what's in the SCL file. Since all of that is green and it looks good, the device is configured as expected, and we can continue our testing. The next one is Goose Tracker, and Goose Tracker shows all the rows here are streams, and the columns are properties of those streams. So you can see here are the devices that are not connected, and here's our device under test, or the Goose stream from our device under test. And for example, this column shows if the stream is present, and we have received a message from it in the time allowed to live. So for the ones that are not there, it's false. For the one that's under test, it's true, and that one looks good. This column shows whether the Goose stream that was found in the SCL file matches what's in the wire, matches what's on the wire. And so for the ones that aren't there, it's missing on the wire. Here it matches. So again, we're looking good for our device under test. We can acknowledge the other devices. Next, we look at LGOS. As Christoph explained, LGOS tells you, oops, forgot to switch. LGOS tells you what the IED thinks it's subscribing to, right? So you read over 62850 MMS what the device is receiving by Goose. Again, the rows here Goose streams, and the columns are IDs. This symbol indicates which IED is the publisher. And so for our device under test is this column 1 right here, and it is publishing, and this Goose stream right here, so that our Goose Tracker sees that it's valid, that you can see on the tooltip. And then it is subscribed to Goose streams from to this Goose stream and this Goose stream, and are located in line 1 LPU1 and line 1 SCU1. So the subscriber status is color coded in this table. You can see that purple means no connection to the IED, which is kind of what we expect here. This is the test. So all these line, we just have our device, and the red means that the SIM status is false on that LOS, so we're not receiving from those strings, which is correct because they're offline, right? These are the transmitters, they're not online. We can also see that information when we hover on these cells. You see the first line in the tooltip shows the status, so you really don't need to look back at the legend if you don't want to. So the red squares on this Goose stream means that our device under test is not receiving that Goose stream. We can also see here that the Goose Tracker is not receiving that stream either. And then you also see on that tooltip what data set members that stream has. And if you go over here on the cell, you can see which of those data set members that IED needs for its internal processing. So same with this guy. So like, for example, the line 1 BCU needs the recloser information and the sync check information, and the SCU needs the breaker failure and the PTRC information. So if that information is needed for the tests that we're doing, we can go simulate that information in the Goose Publisher. We can right click on this stream, go to the Goose Publisher, and it'll highlight that stream in the Goose, excuse me, it'll highlight that stream in the Goose Publisher. So again, here in the Goose Publisher, rows are streams. We can expand out here and show the data items for that row. So this is the data set that is associated with that Goose stream, and these are the data attributes. If I want to change one of these data attributes, I can simply click on it and change the value that will be published by Test Suite Pro for that Goose stream. These columns are properties of the Goose stream that we'll publish, like that sequence number, time allowed to live, application ID. These are the simulate bits that will go out. And we want those to be off since we want the stream to look like the real device. So the organization of these is they're grouped by bay and then by IED. So right here we see the bay and the IED, and then these are the streams within the IED. So go ahead and publish this, and then go back to LGOS. We notice that we are not automatically reading this data from the LGOS. We have an automatic update of the LGOS values that I've turned off for now so that I can demonstrate this. So the value that the chart shows now is that ST should be true because the LGOS that's in the chart the last red value of the LGOS was that it was false. But back over here, our Goose Tracker said that the stream is there. So we show an error condition there that the LGOS should be true. If we go then read it, that will turn green to show that the device is correct and that the LGOS is there. So if we want to go through that one more time with this other one, so on this one, ST SIM was false. I'm sorry, sim was true and the Goose Tracker was true, so we have a green box there. This one, this LGOS status is false, and it matches Goose Tracker, so it's red. But we can go here to Goose Publisher, turn that guy on. Go back to LGOS, update the data, and we are all ready for our unit testing. So now we'll go back to Christoph to demonstrate the system testing applications.
Okay, Christoph, you should be the presenter now. And I would just like to encourage everyone to go ahead and submit any questions that you may have. Want to remind everyone we do have several 62050 experts behind the scenes ready to answer your questions. So it's just a great time to get 62050 questions answered, as well as stuff that you're seeing on the screen.
Okay, so welcome back. I will now go with you through the steps that we typically would do when we do a system testing. We will start to check the system status. That means, is the whole system configured like it is specified from the SCD file? So we will compare the configuration of the system against our SCL file that is loaded in the Test Suite Pro tool. We will verify the presence of all the Goose messages, the subscription status from all the devices. So that's the initial steps. And once we have done that, then we are sure that at least from a configuration perspective, everything works as we want. And then we can start functional testing. And I will just give two examples of functional testing. In the first step, we will show how we can do a control from the client and can test that. And in the second part, we will look into the testing of a protection scheme, a protection and control scheme. In this case, the reclosing that we have as part of our design. Okay, so with that, let's get started. So when we start up, like Jim has explained before, we get this overview. So Test Suite Pro, when it starts up and connects to the system based on the SCL file, it's making a couple of automatic checks for you and summarizes you the result. So what we see now, in this case, we have the whole substation present. We have all devices that are simulating, that are operating, and we see we have a possibility to connect to all these devices. So that's already good. All the devices communicate and we can connect ourselves to these devices. However, in the next step, we see that there is apparently a problem with the model. The model compare tells us there is an error. So let's have a closer look on that. We can select here, we see all the IDs, and when we scroll down the list, Test Suite Pro has marked us the ID with the problem. So apparently the busbar protection unit has a configuration problem compared to what we expect from the SCL file. So we now go on that, we can go through the tree, and for that I will make this a little bit larger. So we can dig into it and we see, okay, there is a problem in the Goose control block. The Goose control block GSCB_F1, and apparently there is a problem with the Goose ID. That's an element from the Goose control block, and when we see over here, the discovered value that we get from the workspace or from the system, the value should be GCP_F1, but according to our SCL file that we have, the value should be GCP_F2. So with that, we can easily find all kinds of configuration errors that we may have in our system, and then, yes, of course, go and resolve them. For the moment, we know that we still have an issue with the busbar protection unit, but we will not use that for the rest of the demonstration, so I don't need to fix it now. But of course, when you want to do the system testing, you need to be sure to fix these things before you use them in your test. The next step we see, we have also a problem with Goose Tracker. So let's have a look. What is the problem here? Apparently we have 3 errors. And if you go down here, okay, we see we have 2 stream errors and we have 1 configuration error. 2 of these messages are from our busbar protection unit that we have just already identified. We have a configuration error. And indeed, when we look what we see here, Test3 Pro tells us it is missing a Goose message with this Goose ID, which is the GCB underscore. No, it's missing that in the file. So it's detecting a Goose message on the wire with GCP underscore F1, but it doesn't know this message. So that's why it declares this message as missing on the wire. On the other side, it is expecting a message GCP underscore F2, and this one is missing on the wire. And obviously, as we just have seen before, because there is a misconfiguration, that's more or less what results in these 2 errors. So these 2 errors here, they are already cleared. That's because of the misconfiguration. So once we fix the configuration of the busbar protection unit, this should go away. But there is another error, and apparently the bay control unit of the transformer bay 2 is not sending, or at least we don't see the message of the bay control unit of the transformer bay 2. So there is apparently a problem, and we need to go and see why this message is not published. We then also have an error in LGOS. So we go now to the LGOS and see what is the problem there. And for that, I make it a little bit bigger here. Now we see the whole matrix. Okay, so we see 2 red squares here. One is the message from BCO1 that we have just detected. It's not on the wire. It's not on the wire, but SU1 should receive it, should subscribe to it. So apparently SU1 cannot report that it gets this message because the message is not there. So that's an expected result of the fact that this message is missing. So that's okay. But then we see also that another message, the one that is sent from the transformer bay 2 switch control unit, Test3 Pro sees the message on the wire, but the BCO1 from the transformer bay 2 that is supposed to receive it doesn't declare it in its LGOS that it received this message. And by coincidence, this is the same device that is also not sending. So I would suspect here is a problem with the configuration of the Goose port on the ID. So that gives you an idea what could be wrong. And then, of course, you need to go into the ID configuration and analyze what is wrong there. But from a system perspective, we can track that down and we see where we have apparently a problem. Okay, so with that, we now know we have a problem with the busbar protection unit. We have a problem with the bay control unit of a transformer bay 2. We can fix those, or we can still start the test with the bays that are working, and that's what we want to do now. So now that we have identified the system is at least for the line 1 and the transformer bay 1, okay, so let's start to do the testing there. And in the first step, what I would like to do, as I mentioned, is to do a functional testing. So I want to verify that a control that is coming in from a client is received by the server. The server will operate the switch and we get the right information back. For that, we can use what we call the custom display in Test3 Pro. What we see here is an overview on the substation with our bay line 1, the bay line 2, the transformer 1 bay, and the transformer 2 bay. We then also see the breaker. We can go to the breaker and we get more detailed information of where it comes from, of the status. We have the busbar switch and we have the line disconnector, so the bus bar disconnector, the line disconnector, we get these informations. We have an option in this custom display to provide you more information. So if you go here, you get the detailed information, where it's coming from, the prefix of that logical node, and you also see with this little symbol here how Test Suite Pro is receiving that information. It is apparently receiving that as a Goose message. But now to test the line 1, we will go to a more detailed diagram that I created, where we now can also do operations. So what we added here is information from the logical node CSWI, which is in the bay controller, which is this part. We see that we receive the information through reports. And I also added information like the operation counter and the open and operate close. As I have quickly shown in the introduction, when we are doing control from a bay control unit to a switch control unit and a communication in between, then we have a Goose message where we have the open signal and the close signal that is sent down to the SCU. And that are those signals that I have also put in this display. Now let's start and try to do a control. For that, we can click here on the open. Test Suite Pro asks me if I really want to operate the switch. I say yes, because I'm in testing the system, so there is no risk behind. The substation is not yet connected, so I click yes. And we see the breaker opens, and the CSWI information as well indicates that it's open and allows us to close. What we also see is that we had here events for the op open, and we had an event for the op close. If I click again on it, now we do the close, and the switch is closing. Okay, so with that, I could in principle test each switch manually. But in order to make that easier, we also have the possibility to prepare test sequences. And for that, we have here the test sequencer. So here we can program a series of operations that we want to do from the Test Suite Pro versus the system under test. And this little test where we test the control for line 1, we basically see that we first do an operation of the breaker, then an operation of the bus bar switch, of the line disconnector, then we verify that all the switches have opened. Before we start the test, we verify that all the switches are closed, and then we close them back again, and we verify that all the switches have closed. Instead of doing that step by step manually, we can do that here as an automatic test sequence. And I will show you how that looks like. So I will start the test here. And in order that you see what is going on, I will show you that in the custom display. So I start the test here. We go to our custom display, and you see the breaker opening. You see the bus bar switch opening. You see the line switch opening. You see the switch is closing again. So the test is obviously at the end, and we can go back to our test sequencer. And yeah, we see everything has passed. So everything is good. We also see that up here where we have graphically all these steps visible as well, how they are executed in sequence. So the test apparently has passed with success. Okay, so far so good. Now let's do the same for the transformer bay. I also have prepared a script here. And now we run that same test on the transformer bay to see if everything works okay. So again, I can start the test, and this time we observe it from the test sequencer. I start the test. The first steps are passed: initialization, breaker closes, busbar disconnector opens, the line disconnector open operation has passed, but now the verify apparently fails. Now we have a red square that means the test has failed. And if we look through and then we abort the rest because we don't know if we still can do the rest. So now if we go down here, apparently there is a problem with the position from the line disconnecting switch. It would be expected to be on, but it's still, no, it would be expected to be off as we switched it off, but it's still on. So apparently we have a problem with the configuration of the line disconnecting switch of this transformer bay 1. Now we want to analyze that a little bit in more detail. What could be the problem? So first we reset the system so that everything is closed. And now we have various means to look into more details. Let's first go back to our custom display and to the transformer bay. So as I mentioned, there should be GOOSE messages with this op open and op close signal going down from the bay control unit to the SU. And in order to visualize this GOOSE message, we can use a tool that we call Logic Analyzer. And here I have the possibility to select signals I receive through GOOSE to visualize them. And in order to do that, I use the data miner. I go to my transformer 1 BCU, and I basically need, I need to go to data miner, sorry. We are on our transformer 1 bay, that's the bay we have tested. We are going to the BCU control. I also show you how an operation looks that was successful. So we will see the operation of the CS of the line, of the busbar disconnector. We want to see the position of the busbar disconnector. So we take the position here. And now we also want to see from the line disconnector, that one that was failing. We want to see the op open, and from the SU we want to get the position of that same switch and drag that over also. Okay, so that are the signals that we want to observe, and now we can start the capture here. I go to our custom display. I first open the one that I know it works. It takes a little time because switches typically have some time to open. And now I try the one that did not work. So we see here the op open is true. So that's good so far, but apparently we don't get a feedback. So it abandons. And if you look at this in the logic analyzer, and we can stop capturing. So we see here the first operation of the busbar disconnector, we had the op open. After a while, the position changed from on to off. So far, so good. Then we tried the other one, and here we never got the position change. And that's why at a certain moment, we had a timeout. I mean, every control operation has a timeout. So when we got the timeout, it aborted. So apparently, the signals that we send out from our BCU seem to be correct, but there seems to be something in the SCU. As we have seen in LGOS, the SCU indicates that it receives the GOOSE message. That's still there. So it still indicates the SCU, the TX1 SCU that is here. It still indicates it receives the GOOSE message from the BCU1, which is this one. So it still receives that. So there seems to be another problem. If we still want to verify, we can also verify with Goose Viewer. We can verify messages. So we can capture messages here. And I can go back to my custom display. I can try and operate again. It sends the open. It's waiting apparently. It's still waiting until this color will disappear. Now it has disappeared. And if I go to the Goose Viewer, I see we have indeed captured a Goose message. We have captured two Goose messages. The first one was when the open went to true, and the second one was when the open went back to false. So the behavior is correct, the Goose message is correct. The only possibility that remains, it's a design error in the device, in the SU internally, that we need to look in the SU itself. But with that, we could at least prove that from a system configuration perspective, everything is working okay. And now we will go to the last test. Now we will do a functional test of protection scheme. And for that, we go back to our overview diagram first. So what we will do now is we will simulate a fault on line 1, a differential fault. And then what we should see, and we will simulate a non-permanent fault. That means a fault that is cleared by the reclosing. So what we should see is the breaker to open, and after a while to close again and remain closed. So if you observe this breaker while I start the test, you should see it quickly turn green and then turn red again. If I click now, it turns green and it goes back. It was apparently a successful reclose. I can now simulate a permanent fault that would have an unsuccessful reclose. And again, you can look at the breaker, and I click to apply the fault. It gets green, it recloses, and it reopens again because the fault was still present. So at least from a first view, that seems to work. But of course, you want to know it for sure, so you want to know a little bit more details. So for that, we want to analyze what is going on with our gooses and what is going on with our reports. We clear what we have captured before. We start a new capturing. We go to report view. We start the capturing. And now I generate again a fault that opens and is a successful reclose. We can stop, continue capturing more signals, and we can go to the Goose viewer, can stop continuing capturing more signals. And now let's see what our breaker positions did. So we can look at the Goose message from SU. If you click on that, we basically see it sent the first Goose message when the breaker position was going off, and it has sent a second Goose message when the breaker position was going on. And if you look at the line protection, you can also look what happened here. The line protection, when we started, okay, we also have the release from the synchro check there, which is always true in our simulation. But we then had in the first message the trip, that was true. The second message was when the trip went back. Then we had the up close from the recloser that was becoming true, and that went back again. So that's the expected interactions of the signals. We also can look at our reports. We can quickly have a look at the report viewer. We have a lot of reports because we have the measurements that are cyclic. We can filter that out. We only are interested in the event-based reports. So we can set the filters. Now we really see the reports that have been created as part of the event, and we can look at the line protection unit where we have the recloser. And when we look at here, we have the recloser has a state. As you know, a recloser is typically a state machine. IC 61850 standardizes these states, and we see those standardized states that we walked through. So we had a trip from protection, we had the fault that disappeared, we had the wait to complete, CB closed, and a successful reclose. So that's what we can analyze based on the capturing we did. So that's more or less the features that you have in Test Suite in TSP Lite. But in the full version, we have some additional means to analyze what exactly is going on with this report, with this reclosing. And I want to introduce that with the signal flow. So we have here another diagram that we call the signal flow diagram. And this is showing the interactions between the different logical nodes and IDs. So everything, so these light green boxes, those are IDs. The dark blue is the logical devices. Those are the logical nodes. So what we see from our design, the trip from our PTRC is routed as a GOOSE signal. You see that on this yellow square here, that this is a GOOSE message, is going as a GOOSE message, GOOSE signal to the breaker logical node. The breaker logical node has the position signal in a GOOSE message that goes to the breaker failure, that goes to the recloser. He typically needs to know the position, but it also goes to the switch control, to the CSWI. The trip from the protection also goes to the breaker failure, and it also goes to the recloser to initiate those functions. And then from the recloser, we have an op close. In our design here, we have decided we do the reclose through the switch controller in order to make a reclose with synchro check. That's where we get the synchro check information in. And then here, what we already discussed before, we have the op open and op close, which is going into our logical node XCBR. So now we can, this is the static configuration. We also show some internal signals. So also those are internal signals. They are not from GOOSE messages. They are not necessarily send as GOOSE message to this breaker failure. We still can capture them from the GOOSE message to visualize. And then you, of course, have also the internal signal that operates from the different protection elements that go into the trip. Now let's try and do a reclose. I can start the recording here, and I can again do a reclosing action. I mean, a fault that will result in a reclosing, and that will all went fast, so it's not easy to follow. That's why we can stop now the recording, and this tool allows us to go step by step through what we have recorded. So we can start. We see the first thing was the op general that became true into the PTRC. The next step, when I click here, was that output, the trip general that became true, and the flashing logical nodes, they received it. As the next step, and those steps now were more or less at the same time. Apparently the breaker has opened. The opening goes back in the position, and as a result, also the fault is going away. And this is all happening more or less at the same time. The position is now indicating the switch is off, the breaker is off, the trip has been taken away. The next thing now is the breaker off, and before it has been initialized, the recloser now will, after the reclosing time, will send a reclose signals to the CSWI. The CSWI itself will send the close signal to the breaker. The breaker will change its position, send that back to the recloser. And as a consequence, also the op close is inactivated, and we are at the end of what was going on. So with that, we can analyze in detail what was happening during our test, how the different events run together. That's one way to look at it. We have already seen before the logic analyzer. Of course, we can also look at that in the logic analyzer. And I already have prepared a set of signals. And we will do a new chart set, but with those signals. We start recording, and I will do again an operation. So you should now see the same thing that we have seen before in the logic, in the signal flow diagram. We now see that as a nice logic analyzer display, like when you would have real physical wires and you would connect your logic analyzer to these physical wires. Now, Test 3 Pro is a virtual logic analyzer that takes the virtual signals that we get from our GOOSE messages. So what we see, what is happening, we have the pdiff that operates, the trip that operates, which sends the recloser into the state strip from protection. After a while, we have the breaker that opens, which sets the recloser in the state fault disappeared. As a result of that, also the operate and the trip signal go away. We wait for the reclose time. After that, the recloser activates the op close. The recloser goes to the state waits to complete. So he waits until he gets the close position back from the breaker. He takes the op close away. Now he is in the state circuit breaker closed. He waits for the reclaim time to make sure that there is not a retrip again. And after the reclaim time, he went to the state successful. He waits for the ready time. And after the ready time, we are back to the state ready. So the recloser is armed again. So there we can nicely analyze that everything behaves as we have designed it. And with that, I hand over to Jim for the final wrap-up.
Jim, before I switch it over to for you to be a presenter, there is just a couple of questions. It would be good to go over as it's something that Christoph just showed.
Sure.
Christoph, can you please explain LGOS and its tracking feature again?
Okay. So LGOS, let me start a little bit before. When we had edition 1, when we had introduced GOOSE, we realized that sometimes when something was not configured correctly, things didn't behave as expected, but it was hard to say, is the communication misconfigured? Does the device really receive the GOOSE message? Or is something in the device logic, in the device connection misconfigured? So it was hard to identify these issues. That's why in edition 2, we decided we need to have a mechanism that we know at least the configuration of the communication is correct. So that's when we introduced LGOS. And an LGOS, an instance of a logical node LGOS, is present in a device. For each of the GOOSE messages, it is supposed to subscribe. So if a device receives 6 different GOOSE messages, like we have typically here for our switch control units, and I can show that again in the matrix. As an example here, the switch control unit from line 2 receives 6 different GOOSE messages from different senders. And so we have 6 LGOSes in that switch control unit. And whenever the communication stack receives the GOOSE message that he is configured to, he will indicate in this data object ST, which is the status of the subscription, that he receives it. Then we know at least the communication is designed correctly. So if we still have problems, then it must be a wiring internal in the IED. The LGOS is also useful when we talk about simulation, virtual testing, virtual isolation. which we will do in one of our future webinars. But so basically, when we have simulated streams on the wires compared to the real ones, simulated streams from test equipment, for those of you that are a little bit familiar with that, we also would see in the LGOST that the device is now receiving a simulated stream, so it's ready for the test and it's prepared and isolated. So I hope that answers the question.
Mm-hmm. As a follow-up question, is LGOS mandated in addition to?
No, it's not mandated, so it's still left to the designers of IDs, but if you are a utility, I would strongly recommend that you request from your suppliers to include it, to have it available.
From what you explained earlier, does that mean the IAD should support the logical node LGOS?
As I said, they are not mandated, but I would strongly recommend, and as an ID manufacturer, yes, I would strongly recommend you to support that, because it helps your customers. It also helps you when you have to do some testing of your devices.
Okay. Because of time, I'm going to go ahead and switch it over to Jim. I do see a lot more questions coming in, a couple of them also on DTM, which we will get to. But Jim, in the meantime, I'm going to make you presenter if you want to go ahead and take it over, and then we'll wrap up shortly from there with addressing more of the questions.
Okay. All right, so we have created a toolkit for 61850 that contains all the products that support the protocol. Hold on, let me. Can you see my screen okay? Is everything working? We
can, just put it on presentation mode.
Yeah, I think I didn't quite click it. There he goes. Okay. The first part of so what we did was divided this functionality into 3 executables so we could simplify these applications. You know, if you take Test Suite Pro into a substation, you want that to be as simple and straightforward and obvious as possible. So we split this functionality out. We split the other functionality out into separate applications so you could have the simplest thing in Test Suite Pro. And as we saw today, you can validate, troubleshoot, and do simple automated testing with Test Suite Pro, and you can visualize substation data during the test. For DTM, that was what was driving the simulations behind Test Suite Pro during the demonstration today. And to create that simulation, DTM can parse an SCD file and automatically create a majority of the behavior to simulate logical nodes in the substation, like the recloser that Christoph showed you. DTM can also do complex automated testing to validate things like gateway mapping, state tables, or test sequences from a spreadsheet. It can also test reaction of a system to a simulation of extreme conditions that are difficult to create in real devices. For Navigator, like the name says, it navigates between related items in an SCL file, such as report control blocks, data sets, and data objects. It also automatically detects errors in an SCL file, and it can fix errors in those SCL files. They don't so they don't slow up a project waiting on revisions from another department or a vendor. These changes can be tracked by Navigator by comparing the original SCL file to the revised file, and they can later be fixed long-term at the source, such as a vendor or another department managing the system configuration tool. So this shows the progress of a typical project, going from concept and design to factory automation testing to commissioning and maintenance. And we have Test Suite Pro going through all 3 of those phases. And DTM simulating everything in the concept and design phase, which is then monitored by Test Suite Pro. Once we get to factory acceptance testing, the IEDs that we have available, we put them in the system, we turn those off in DTM, and we use the same workspace in Test Suite Pro that we developed during the concept and design. And you really shouldn't notice a difference in the operation of the system there. But that tests the IEDs that you have available at the time. Once you get to the substation, you take those same workspaces with Test Suite Pro, without DTM, and you can you're very familiar with the way they're set up and what behavior you should see because you've been working with them for a while. So the way this relates back to the 61850 engineering process, you have the ICD files from the vendors that come into Navigator. You can compare different versions of those files and see what's changed in them. Maybe some errors got fixed or something got broken. But you can compare and see what the differences are. You can verify and see if there are any potential problems in there, and then you can also fix those. Like we were talking about before, if you need to keep the project moving, and then get back to the vendor and have them fix the original file. So you put those into the system configuration tool and create an SCD file, which can then be passed on to the IED configuration tools, loaded in the IEDs, passed on to DTM, loaded for the simulation, and passed on to Test Suite Pro to monitor and troubleshoot. So during operation and maintenance, many of our customers are continuing to use the DTM workspace created during development to feed their Scada master that's used for training. They can also test new devices on this network and monitor or drive the testing with Test Suite Pro. Technicians can also be trained and evaluated on this network to diagnose and repair common issues that are seen in the field. Now we'll go back to Beth to finish up for questions.
Okay. Let me just go ahead and take the screen back. Just give me 1 second. Okay, so we are getting to the end of our hour, so I do want to just wrap up real quick. Just in case you came in late, or a lot of people have asked this questions throughout the whole webinar, you will be able to review what you saw here today. We do post all our webinars onto our website, onto GoToWebinar, as well as a YouTube channel. I also wanted to point out that what you've seen here as part of the 61850 engineering process has referenced Helix as a system configuration tool. We do act as a reseller for Helix, so please feel free to contact me if you'd like to learn more about that or to set up to see a demo. And then, as I mentioned, this does conclude the presentation part of the webinar, but we still have quite a few questions that haven't been answered, so we're going to go ahead and start to go through the questions and answers. Please feel free to continue to submit them. We will stay on as long as we have questions. So now is a great time to definitely ask the expert. So with that, I'm going to kind of go back to where we had left off with LGOS. There was a couple of other questions around that related to DTM as well. Can we supervise LSVS as well as similar to LGOS using DTM? I'll throw that out to Christoph or to Jim or anyone else.
I just responded that one in the chat.
Oh, did you?
LGOS is supervised. I mean, the visualization of the value of LGOS is not made by DTM, it's made by Test Suite Pro. So it's reading the logical node from the server. So it's made by Test Suite Pro. And yes, we can do the same with LSVS with the sampled values. In principle, we don't yet have the matrix as such designed because we don't yet see so many LSVS, but in principle, it can be done as well.
Okay. Is RGoose and R sample values supported as well? If not, is this on your roadmap? Throw that out to Christoph or to Jim.
Sorry, I was muted. Yes, we do support RGoose.
Okay. Here's a little bit more of a high level question. Can you explain the differences between DTM and Test Suite Pro?
Well, DTM is for simulating large and complex systems, and then also doing more complex testing scenarios where maybe you need to simulate a slave, go through a data concentrator, and then simulate the master above that to verify you got the right data through the data concentrator. Whereas Test Suite Pro is more for monitoring and diagnosing things in, either on a simulation or in the substation or combination thereof. And it does some very simple simulation of a Goose stream or just of one or two IEDs, but not a whole complicated system. And it can also do a simple test sequencer test where you have a sequence of commands you're sending out and validating values and so forth, but not the kind of going into the simulation and changing values and then seeing how that affects the operation of the device under test.
Okay. When a subscriber receives, which attributes in LGOS has to be checked for confirming the receiving?
I probably can take that one. As I mentioned, I think I mentioned it in the LGOS, we have a couple of data objects. I'm not sure if you can go back to the slides if you want me to make me present it again.
Sure, I can do that.
Yes, then I could show you the slide that I have from the LGOS because I think that's the easiest.
Okay, you should be presenter.
Yeah, and you should see my screen. So here is again the logic in node LGOS as it is defined in the standard. And it's this data object ST, which is a single point status. So it has a data attribute STVal. If this becomes true, that means the IED is receiving that Goose message. And if this is false, that means the IED is not receiving the Goose message. And in order to know to which Goose message this applies, we have here this configuration setting, the Goose control block reference. So that's where we refer to the Goose control block, which message that we indicate based on that LGOS. So as I mentioned before, if my SCU, my switch control unit, is receiving 6 different Goose messages from 6 different devices, it will have 6 of these logical nodes, each of them configured to one of the Goose control blocks of the sending device to the one that it has to subscribe. And in the ST here, it will indicate that it receives it, that the subscription is working, that he gets the data. The simulate status that I mentioned before, that's where you would indicate it that he gets a simulated message as well. I hope that answered the question. We have additional information like which was the last state number that we received from Goose, what is the expected configuration revision number. That can also be helpful in some problems when we don't really subscribe correctly. That can be a misconfiguration or whatever. So you can get a lot of valuable information out here.
Okay. Do we know what IED manufacturers support LGOS and LN nowadays?
I'm not up to date with all the latest, but I would, based on what I have recently seen, I think most of the IED manufacturers, the larger ones, are now supporting it. But I cannot guarantee. I would need to check. I'm not sure, Jörg, you have to deal a lot with customer projects. Are you typically starting to see LGOS there for the different manufacturers? Maybe Jörg can answer that. But Jörg, you would have to, yeah.
Yeah, I need to always find the unmute button. Yeah, as you said, the big vendors, they meanwhile all support the LGOS and also LSVS if they support sampled values. The way the LGOS is configured is a little bit different from between the manufacturers, but the support is there. I know some smaller implementations, smaller vendor suppliers. I think they do not have it all. But for the bigger companies and in let's say the newer relays, so the latest generation of relays, there you can find the LGOS nearly everywhere.
Okay, thank you, Jörg. Do we need real IEDs for this software to work? Can we just use the simulation software with relays ICD files?
Yes, you can just load the ICD file and simulate from that, or you can load an SCD file and simulate the substation and the interaction that's been defined in a system configuration tool like Helinx to define the behavior of the substation.
Okay. Can we analyze IEC 61869-9 SV profile using DTM? And how many sample value streams can be analyzed together?
Is Shri on the line? Could he take that one?
Yeah, first of all, I think it's not DTM, it should be TestSuite Pro. I mean, we analyze the messages with TestSuite Pro, not with DTM.
DTM would generate the simulation of them, whereas TestSuite Pro would analyze the evaluation.
Yeah.
So right now in TestSuite Pro, we have a sample values tracker, like we have the Goose Tracker, and it shows the streams that are out there, and you can track the streams that are on the wire. I'm not aware of any limit on that, but we could certainly test that and see what the limit for the number of streams is. It's just like a Goose Tracker in that you see the sample value streams as rows, and then as columns, you would see the different properties that each stream has, either defined in the SCD file or on the wire.
Okay. Is the tool able to test sample values and digital status through process bus?
Can you repeat the question?
Sure. Is the tool able to test sample values and digital status through process bus?
Well, I think digital values would probably be Goose values coming over, right? Would you agree, Christoph?
Yeah, I would assume so. And yeah, basically when the tool is connected to the process bus, then that's what we basically just showed. Yes, then you can analyze the Goose messages on the wire, and you can analyze sample value messages on the wire. So yes, it can.
Okay.
So we don't really care whether you have a separate process bus and a station bus. We can connect to multiple adapters. You just tell it where the source of your signals are on which adapter, and it will just kind of combine that all into one display and show it together.
Okay, the next question I have here is going back, Christoph, to when you were showing test sequencer. Is it possible to parameterize these sequences? Sometimes the bays are very similar, only IED names are different, but the projects are copied from a template, for example, so all the logic is the same.
At the current state, not yet, but it's definitely planned for as one of the next features.
Yeah, if you'd like to get back with us on that, we're looking at different ways to do that, different approaches. If we can look at how your data is organized and how you templatize that stuff, maybe we could optimize our implementation of that to fit your application.
Okay. Can you explain what is LSVS and how it differs from LGOS?
Yeah, in principle, it's almost the same, except that it has, as the sampled value configuration has a few different parameters than the Goose configuration we have seen before, the LGOS data that I have shown. So some of these things like needs commissioning or so, last date number, of course, the last date number doesn't exist in LSVS. But the key elements like the reference to the control block, the ST to indicate that the subscription is okay, or the sim ST to indicate that I receive a simulated status, they are the same. And it is the same behavior. It's just as the Goose message has some different characteristics than a sample value message, some of the data objects in the LSVS are different than the ones in the LGOS.
Okay. Here's one asking about both DTM and Test Suite Pro. How many IDs can be simulated in DTM and how many IDs can be monitored, specifically Goose, with the help of Test Suite Pro?
Typically, the biggest systems we're seeing these days are about 200 IEDs. It's going to depend really on the complexity of the SCD file and the complexity of the IEDs, the number of data attributes and logical nodes that are in each one. I mean, we haven't run into any performance limitations. The fact that DTM is distributed across multiple computers, we can always expand to more computers to host more devices. And you could do the same thing for Test Suite Pro, where you can limit the scope of the Test Suite Pro workspace that you're using to, say, a bay or something that you're focused on. So the size of the substation is not really a big concern.
Okay. Well, I think that wraps up most of our questions. I see the questions starting to slow down. It looks like we've answered majority of them online as well as in person here. We will be sending out a link to the recording of this webinar, as I mentioned earlier, as well as a copy of all the questions and answers that were asked on the webinar. So I appreciate everyone taking the time to spend with us and learn a little bit more about our tools and hanging on a little bit longer to get through everyone's questions. And we look forward to hearing from you at our next webinar. Thanks everyone for joining today.
Thank you.